Welcome to the new video. Previously, we was learn about LED interface and some modifications to control a LED, like using a push button, how to code it, what is a circuit diagram, and what is the specifications of electronic devices. In this new video, we were we are going to learn about how to interface the RGB LEDs. Yes, we are going to learn about what is RGB LED and how to interface the RGB LED with our microcontroller unit, Arduino Uno. Here you can see this one is a RGB LED. It has a four terminals. Yes, it's a four terminal device and it's basically a light emitting diode, but with a three different type of the colors. In this video, we are going to learn some introduction, what hardwares are required to interface the RGB LED with the microcontroller unit, what will be the circuit diagram, and how we can write a code for a RGB LED, and how we can operate the RGB LED and this and its color combination with our programming method. Let's see an introduction. So first of all, we will understand what is the RGB LED. So an RGB LED is a combination of three LEDs in just one package. As you can see, the RGB LEDs name R, G and B. Yes. So these all three alphabets are stands with the meaning. So R stands for a red color, G stands for a green, and B stands for a blue. There are two kind of LEDs. Yes. This classification is based on the pin configuration of RGB LED. So one is a common cathode and another one is a common anode. You guaranteed different color. You generated different colors by adjusting the brightness of each of the three LEDs of RGB LED. To adjust the brightness of each LED, you have to use a PWM signal. Yes, the PWM pins of our microcontroller board are used here in a RGB LEDs. So in this tutorial, we will learn about our Arduino RGB LED interfacing. The RGB LED consists of three different uh, LEDs. From the name, you can guess these LEDs are red, green, and blue. As I mentioned before, we can obtain many other colors by mixing up that three colors, and we can generate some color combinations, and we can produce some new colors by using these three basic colors. In science, these are the basic colors, and all other are the combination of these three colors, red, blue, and green. The Arduino has an analog write function, which help us in obtaining a different color for Arduino RGB LED. The human eyes has only three cones. In most of the people's, the human eyes are only cones. These cones are detected for a red, green, and blue. Yes, our human eyes can just detect these three primary colors: red, green, and blue. Apart from this, all three colors, all three primary colors, the all colors are the combination of these three colors. Yes, like if you will mix yellow and green, you will find a green color. So by mixing up these three primary colors, you will find another color combinations. However, LED and LCDs are only capable of displaying those two color individually. These LEDs can be mixed to show different intensities of these three colors. Because of all small size of each LED, your eyes are tricked into seeing a different color that aren't actually there, which the with the Arduino and a technique called PWM. The full form of the PWM is a pulse width modulations. Uh, we can pulse each color of the LED separately to create a many different colors. The PWM of the Arduino is programmable from a 0 to 255. Yes, the value of the PWM pin is lie between 0 to 255, or we can adjust the value of a PWM in between 0 to 255. 0 would be off and 255 considered would be 100% brightness of a RGB LED. That's 256 possible variation. Yes. So from 0 to 255, it means there is a 256 total number of variation. This gives us total number of 16777 possible color to play with. Yes, we can generate around 16777 possible colors to play with. Let's see what is the type of RGB LED. So the RGB LED is a type of a LED that you can produce three main colors as we uh, mentioned below, that are a red, green and blue. In other words, we can say that it's a single LED that contain all three primary LEDs inside. One of the red color, one for the green, and the last one is for blue color. The RGB LED that we are going to discuss in this video is non-programmable, and it is of a two type. One is a common anode type, as you can see in your left hand side, and another one is a common cathode type, as you can see in the right hand side of the screen. A common anode RGB LED consists of four terminals. These common anode and common cathode, both LEDs consist of four terminals, but it basically classified on the base of the polarization of these two LEDs. So let's see two separately. A common anode RGB LEDs consist of a four terminal, out of which one of the common anode, one is for the red LED cathode terminal, one is for the green LED cathode terminal, and the last one is for blue LED cathode terminal, as you can see here. All of these three LEDs is shorted internally and connected to one terminal, and that terminal is known as a common anode terminal. Here you can see that it's a common anode terminal. This one is a red color and this one is a green color, and the last is this one terminal is for a blue color. In the other hand, a common cathode RGB LED also consists of a four terminal, but in this type of RGB LED, one terminal is the common cathode. Yes, this black mentioned text is show the common cathode terminal. One is a red LED anode terminal, one is for the green LED anode terminal, and the last one is for a blue LED anode terminal. We call it a common cathode RGB LED because in this type of a LED, the anode terminal of all three LEDs is shorted internally, connected to one terminal, and that terminal is known as a common anode terminal. As you can see here, the three LEDs are red, green, and blue. In these three terminals, one terminal is shorted commonly, which is a common cathode terminal. That's why it's classified as a common cathode terminal, and same as a common anode terminal. The anode terminal of the three, this primary color three LEDs are shorted internally. Let's see applications of RGB LEDs. We can see in the decorations like festivals, Diwali and Navratri, the RGB LEDs are used to decorate some functions or some festivals. We are familiar with this RGB LEDs. The second application is hydrophonic and aerophonic, then the backlight, then the room light, and the traffic lights. RGB LED are also used in some cases where we need some indication through a light, or we need some photosynthetic part of in our project. We can use the RGB LEDs. Actually, to light up a common anode RGB LED, you have to connect this common terminal to the positive terminal of the power source. Then to light up the red color, connect the red color terminal to a negative terminal of the power source. Do the same for the other colors. You can also light up two or three colors simultaneously. Then you will get different color combinations. Let's see again the terminal details of the RGB LEDs. Then you can understand clearly. To light up a common cathode, let's see light up the common cathode LED. To light up a common cathode RGB LED, you have to connect it a common terminal to the negative terminal of the power source. Then to light up the red color, yes, to light up this red color, connect the RGB LED terminal to the positive terminal of the power source. It will also work in the same manner as that of the common anode RGB LED. By directly applying a voltage to both the type of a LED, you can get the red color, blue color, and green color. A combination of the RED and red and blue color, a combination of a red and green color, a combination of a blue and green color, and combination of all these three colors. So you will get a total number of seven colors. Yes, by the combination of the red, green, and blue colors, you will get a seven number of colors. So we cannot apply this four terminal to the same time, and this three terminal will get same power supply at the same time. We need to control that these three colors, so we can operate our RGB LED as per our requirement. Let's see uh, what are the hardware requirement. So here basically, we first of all we need a Arduino Uno microcontroller board, then computer for a programming, some jumper wires, one breadboard, one RGB LED, and a register with a register value or suitable register value. Let's see a circuit diagram. Here you can see the connect the cathode of a RGB LED, which is the longer pin of a RGB LED, to the ground of the Arduino. Yes, you can see here the common cathode pin, which is a second number from the left hand side of your screen, is connected to the ground. And here the red color pin is connected to a 11 number PWM. The green pin is connected to 10 number pin of a PWM, and the blue one is a 9 number of a PWM. So connect the cathode of a RGB LED, which is the longer pin of a RGB LED, to the ground of the Arduino, and the other three pin to the connected to the 11, 10, and 9 of Arduino through a 220 ohm resistors. This register value, we can choose the value of the resistors as suitable per the equipments. We can take here, we can take a RGB LED, so 220 ohm resistor will be enough for this project. The resistor will prevent the excess amount of current to flow through the RGB LED. If you are using a common anode RGB LED, then connect the long end to the 5 volt Arduino. That is the main difference between a common anode and common cathode LED. Let's see a code. So how can we code and how can we control the LEDs, the color of a LEDs by using a microcontroller? Let's see. So, as usually, first of all, we will define the configurations or pin configurations for the RGB LED. So, for a red color, the pin is connected to a number 11 of a microcontroller. For a green, we connect a 10 number PWM pin for a green color, and in the last, the 9 number, which is also a PWM pin connected to the blue color. And these all LEDs are basically output devices for a microcontroller board. Now, because we connect our LEDs to a PWM pin, as I mentioned before, the PWM is basically a pulse width modulation, and it is a vary between 0 to 255. So we will get some another color combinations. So if we need some color combinations, then we can adjust this value according to our color combination. But in this scenario, we just need a red, green, and blue LEDs. So let's take a basic example, and we will operate these colors. First of all, we are going to turn on the red color, and at that time the green and blue color are going to be off. So for red color is connected to a PWM of Arduino no, is in number 11. So we will just give a high output to a 11 numbers pin, and the 9 and 10 pin number will remain off. So here we can see that set PWM pin number 11 out is a 255. So 255 for a PWM pin is a high output, and 0 will be a turn off for other LEDs. So in this section here, we can see that our red color is being lighted, and green and blue color are remaining turned off. And here we take a hold or a delay for 1 second by using a wait 1 second block. In this second logic or second scenario, we can see that here we need to turn on the green LED. So for the PWM pin 11 and 9 will remain turned off, and the for the green color which we can attach to a 10 number of PWM pin to the Arduino microcontroller. So PWM pin 10 will be on a high state. It means we have to write a 255 value to a PWM pin of a 10. Then again we put a delay for 1 second. Now in the last, we need to operate, or we need to glow a blue color, and the red and green will be off. So here we need to write a 255 value to a pin number 9, and 10 and 11 are going to be off. So the blue color will glow on the RGB LED. First of all, we need to understand the what is a PWM. Let's have look some basic scenario of a PWM pin. Actually, the brightness of the LED is proportional to the current going through it, but it would be rather different to use a microcontroller to accurately control the current flowing through an LED. Fortunately, human vision has a nice phenomena called persistence of vision. So, persistence of vision is the phenomena where an image that is seen for only a fraction of a second will continue to be seen by your brain even after the original image has vanished or removed. This the same principle behind the film and television also, where we where a rapidly changing image tricks your brain into a seeing continuous motion. By turning our LED on and off repeatedly, we can trick the brain into seeing a average value of a brightness based on the duty cycle of the driving PWM signal. So the PWM signal pulse with modulation signal is a practice of modulating the duty cycle of the signal used in the application to control the average power sent to each LED. In the following figure, we see that a different duty cycle in first 20 50% duty cycle, then 10 and 90 and duty cycle is going to the up. So this is all how we can control the PWM signal by using the PWM pin in a microcontroller board. uh, let's have a look with how we can generate colors using a RGB LED. So we can also mix up. We can also generate some new colors by mixing up the red, green, and blue color. To generate a wide range of a color using an RGB LED, just varying the brightness of the individual R, G, and D LEDs. You might already have a perform an experiment with a dimming an LED using Arduino, where the brightness of the LED is controlled either directly using the program or by interfacing a potentiometer. Yes, we can study about that. We already study about the potentiometer by using the by using the Arduino. So potential are basically used to control the flow of the voltage, and we can indirectly control the brightness of the LED. The technique used to control the brightness of the LED is called pulse width modulation, or simply PWM. Or by if we know if we don't want to use the potentiometer in this, so no, not it's not possible to every time we can connect the individual potentiometer for an individual pin, right? So here we can connect those our pin where we need a PWM signal, or where we need to control the brightness. We can connect those pin to our PWM pin. So PWM is a technique where the amount of a power delivered to a device can be controlled accurately or efficiently. PWM technique can be used to control the brightness of an LED. The speed of a motor or a direction of a servo motor can be changed by using a PWM pin. There are two important factors to consider when dealing with the PWM technique. One is a duty cycle, and another one is a frequency. So we will see about this duty cycle and frequency in our next videos. But let's mention the RGB LEDs pin specifications, so we can clearly understand that how can we use this electronic device in our projects. So the forward voltage of a red color is basically a lie between 1.8 to 2.2 voltages, and for a green it will be a 3.0 to 3.4 voltage, and for a blue color it will be a 3 to 3.4 voltage. These are the forward voltages for the RGB LED. Let's talk about the forward current. For a red color, the forward current will be a 20 milliampere. For the green color, it will be a 20 milliampere, and for the blue color also it will be of 20 milliampere. So forward current will be the same for the all three colors, but the forward voltage will vary for individual color. Let's talk about some reverse current. Let's imagine that our RGB LED is connected to a 5 voltage, and let's talk about the reverse current. For the red color, for a green color, and for blue color, the reverse current will remain the same, which is a 10 microampere. Let's talk about the illumination intensity. Okay, so for a red color, the illumination intensity is a 800 MCD. For a green color, it will be the 4000 MCD, and for a blue color, it will be a 900 MCD. Let's talk about the operating voltage of a RGB LED. So the voltage or operating temperature of RGB LED is minus 25 to 85 degrees Celsius. Yes, our RGB LED can maybe in between this temperature, which is a minus 25 to 85 degrees Celsius. And so this is all about the RGB LEDs, which we can use widely in our routine days. We can see in a festival or a function, the RGB LEDs are all over where we can see that. This is all about the RGB LED interface with a microcontroller unit, and some primary knowledge of the basic colors, which are red, blue, and green. Here, uh, let's see some other part of the code. Let's move forward. So we can see that, okay, if we need to raspberry color, we need to go to a out of the primary color, where we can need a raspberry color. We just need to set the PWM 11 pin to a 255, set the PWM pin 10 to the 255, and 9 will be on 125. It means we have a color combination of a red, blue, and green. We just need to down the intensity of the green color, then we will have a raspberry color. And then hold for a 1 second. Let's talk about another scenario. If we need a cyan color, then we just need to turn off the red LED, because here in a cyan color we don't need a red color, we just need a blue and green color. So by mixing up the blue and the green color, we have another combination of a cyan color. Let's talk about a magenta color. So when we need a magenta color, we don't need a blue color. So uh, we have just mixing of two colors, which are a red and green. So by mixing up the red and green color, we have a magenta color. Same as a yellow color, as I mentioned before. When we mix a red and blue color, we have a yellow color. We don't need a green color here. So in a white color, we just have all three colors. If the all three colors are glow at the same time, we have a we will produce a white color. So this is basically a requirement. And what is the use of a PWM pin? What are the PWM signal? PWM signal is basically generate or basically control the brightness of the colors. We whenever we use to this PWM pin, we can operate the control of the motor also. So we don't need a potentiometer to control the brightness of the color. Hope you are enjoying well in this video. Thank you so much.